We've talked about materials properties like compression strength and toughness, but where do these properties come from? Why do materials behave so differently from each other? If I tell you that ceramics are made of crystals, then you may have some idea of why they're brittle. But if I then tell you that steel is also made of crystals, you might be surprised. In fact, that wall is made of crystals. The silicon inside this laptop is a crystal. The housing around here, this aluminium, that's also made of crystals. So quite a lot of the world is made of crystals. And in order to understand why they behave differently from each other, we need to zoom inside the material and have a look at those crystals. So I have a piece of steel here. Let's use this microscope to have a look at its internal microstructure. And you can see that little pattern is the crystals inside the steel. Now, I can take you on a journey even further by using graphics. Let me take you on a tour. The first thing to notice is that the steel is divided up into a patchwork, and each individual patch is a crystal. If we zoom in further, we find iron atoms individually arranged in a regular way. And that's what a crystal is, a regular arrangement of atoms. If we zoom out again, we see little lines, and these are where the atoms inside the crystal have been disrupted. These are called dislocations, and they are what make metal crystals so special, because they can move. When they move, they change the shape of the crystal, and so they change the shape of the metal. That's what happened when I dropped the steel coffee cup. Billions and billions of dislocations inside billions and billions of crystals moved, and they created that dent. That's why steel is tough, and that's why most metals are tough, because their dislocations can move. Inside the crystals of the ceramic coffee cup, there are dislocations too, but they can't move. And because of that, the stresses build up and cracks form and the whole cup shatters. You can appreciate then that if you can manipulate how many dislocations there are, or how many crystals there are, or how they interact, or many other aspects of the microstructure, you can change the properties of steel. You can make it tougher. Have a look at this. Normal steel coat hanger, I bend it. Nothing strange about that, except of course that you realize that in order to bend it, I had to move billions and billions of dislocations inside billions and billions of crystals in order for the steel to be able to bend like that. But now, if I was to zoom into the microstructure inside these steel crystals, we'd find all the dislocations that had caused that bending. They've all piled up and tangled with each other. So then, if I try and bend it back, they've got to move again, and that's more difficult because they're tangled up. So it should be harder to do that. Let's see. Yeah, it's harder to bend it back. So that's odd. That means the bend strength has been increased. This metal has got stronger by me bending it. That's odd, but it's very useful. It's called work hardening, and it's the reason why blacksmiths hammer metal, to make it stronger. So we can see that by understanding the microstructure, we understand the properties of steel.